Hey guys, so today you should have already graded your homework about proportions and similar figures. Take a second if you need more time to answer these two questions for the warm-up today. The first one is, can you cross multiply to solve? This is a yes or no question, but make sure you're able to explain it as well. And then number two is, I want you to solve for the variable x. So I'll give you a couple more minutes to work on that. When everyone's done, push play. Okay, so for the first one it says, can you cross multiply to solve? Raise your hand if you said yes you can. And who said no you can't? Okay, so if I look at this, cross multiplying is if you have two ratios equal to each other. In this case, for the second one, I have two ratios equal to each other. I'd be able to cross multiply to solve. However, this one has two ratios equal to each other. However, there's a plus 1. So this 1 plus makes this not possible to cross multiply and solve. If it was only just b minus 8 divided by 5 is equal to b plus 3 over 4, this would be yes you can. But because we have this 1 attached to this side, we would have to solve this a little bit differently. Okay? So I just wanted to point that out. Now number two we should be able to solve because this is what we worked on yesterday. This is a proportion. Okay, now again this is a little bit different because in algebra now we're having a couple terms as the numerator or the denominator. So no matter what, again I hope that you put parentheses around this. If you didn't, do that now. Okay, the first thing I'm going to do here is to cross multiply. So I'm going to go ahead and circle what I need to. I'm going to draw my line down the equal to sign. So I have 12 parentheses x plus 3 on one side and then 7 parentheses x plus 4 on the other. Now to simplify this or get rid of those parentheses, I'm going to have to distribute. So I'm going to distribute that 12 on the left side to everything on the inside. So 12 times x is 12x. 12 times 3 is 36. On the right side, I'm going to distribute that 7 to the x and the 4. So 7 times x is 7x. 7 times 4 is 28. So hopefully you got to that point. Now I'm just using my rules or my steps to solve for x, to isolate x by itself. So I'm going to move my variables first off. So let's move this 7x. Now again, you might have moved something else, but you should end up getting the same exact answer. So I'm taking 7x away from 12x, which gives me 5x plus 36 is equal to 28. Now that my x's are on the left side, let's move our numbers or our constants to the other. So I'm going to subtract 36 on both sides. So I'm left over with 5x is equal to negative 8. Let me double check. 28 minus 36 is negative 8. And then I have to divide by the coefficient. So my answer ends up being, you can keep that as a fraction, negative 8 over 5. Or if you simplify that to an actual decimal, negative 8 over 5, I know it's a negative number, negative 1.6. So my answer here is x is equal to, if you keep it as a fraction, negative 8 over 5. Or negative 1.6. Okay? Very good. Now, today we are going to continue, and we're going to be solving inequalities now. So, on the next page of your journal, go ahead and head it Solving Inequalities. We're going to be graphing these as well. This is just an introduction to before we get to the more detailed inequalities that you're going to have to solve. Make sure you head your journal. This is my page 22. I'm going to go ahead and label that in my table of contents as well. I added graph as well to that, but you don't have to. Solving inequalities or graphing, this is my page 22. And as you're writing that down, think of what are inequalities. There's some posters hanging up around the room that have the inequality symbols on there. And if you notice, the word equal is in there. But again, this is an inequality. So if we write down some inequality symbols, once I give you one, I'm sure you're going to know the rest. inequality symbols. The first inequality symbol, now inequality just means not equal to, okay? So it has to be something else. So this first one, which is an equal sign with a dash through it, just means not equal to. And we saw that when we were solving equations, when there was no solution, we ended up having two numbers that were not equal to it, so it made a false statement. Another symbol that shows that it's not equal is this symbol. Now, is that symbol greater than or less than? In algebra, we no longer have the alligators eating the bigger number, okay? Because again, we don't have numbers on both sides. We have variables. So, you're just going to have to find a way to remember that this symbol right here represents greater than. Which means this symbol represents less than. One thing that helps me remember is this symbol right here. Let me do it on a post-it note. If I just turn it a little bit, it makes an L shape. So that's how I remember it's less than. So here's this less than symbol. I just turn it a little bit, it makes an L. So that would be my less than sign. Okay, and then we also have a greater than sign with one little dash under it, and that just means greater than or equal to. And then we also have the same with less than or equal to. So if you look at the title of what we put, solving inequalities and graphing them, we're actually not going to have an equal to sign anymore. When we solve equations, we're going to be solving inequalities. So it's very similar to solving equations. It's just there's a couple different steps that we need to take and things to remember so we're successful at this. So if we define an inequality, okay, what an inequality is a statement where two quantities are not equal. So that's why we have these symbols, because we're going to use one of these to show that they're not exactly equal. One side might be greater than the other, or the other side might be less than the other. It just depends. We want to make the statement true at the end, so it's not always going to be equal. Now, just like equations, when we're solving these things, we have to make sure that the variable is always on the left side. Of whatever symbol we have. Whether it's less than, greater than, or has that equal to bar. Our variable is always on the left side. So an example, okay, if we ended up solving something and it was negative 34 is less than x. Okay, that would be incorrect because again our variable's on the wrong side. We need to change it to x is greater than negative 34. Now again, if I just look at this symbol, it's opening up to the x. So when I rewrite it, I have to make sure that it's opening up to the x. So, as a little helpful hint, when you rewrite it, we have to make sure we flip the sign to make sure that it is still representing the same exact outcome. So again, if it's opened up towards the x here, it has to open up towards the x there. So we're going to have to flip the sign when we rewrite it. So basic inequality stuff. Usually we use inequalities to represent many solutions here because again if something's less than or greater than, it's going to be multiple solutions. So if I give you a word problem, say that you're starting a new job and you're applying for it, and one of the requirements is that you must have at least 3 years of experience to apply. And some of you guys might be filling out job applications maybe this upcoming summer, so you can start making some money to save up for college. So this is something that's good. So the way that I would write this inequality is, first I have to pick a variable. So if I'm describing that we must have at least 3 years of experience, let's just say y is for years experience. You always choose a variable, doesn't matter what it is. Now usually the number that they give you is what we're going to be comparing it to. So if I have years experience in 3, what inequality symbol could I put in here that will allow me to apply for this job? Okay, again, I must have at least 3 years of experience. So is that less than 3 years experience or more than 3 years experience? Okay, I'm going to have more than 3 years experience because it says at least. That means at the very minimum 3 years or more. Now, can I have 3? Because it says you must have at least 3 years of experience. So can I have 3 years and still apply? Yes, I can. So this one's also going to have that equal to bar. So when I write this inequality, and I say it out loud, is the year's experience must be greater than or equal to 3 for me to apply for the job. Okay, if I graph this, we're going to be graphing it right now on a number line, but eventually we're going to be graphing it on a coordinate grid. Again, the middle number of what I'm comparing to is 3, so I'm going to put 3 in the middle. I usually put just 2 on the left and 2 on the right, so 3, 4, 5 is going to be 2 and 1 over here. Now to show the graph of this actual inequality, there's a couple things I need to remember, and you should have known this from last year. To show that it's 3 or more here, because again y is greater than or equal to 3, I'm going to have something on the 3. Okay, it's usually an open or closed circle. So at the bottom, you need to write this down because this is huge. If it's an open circle, which means something like this, on that little dash mark above the 3, that's when I use the less than or greater than sign. If it's a closed circle, it's going to be like shaded in. So a closed circle looks like this. And that's going to include our less than or greater, or less than or equal to sign, or our greater than or equal to sign. Now, one way I remember the difference between greater than or the closed circle or open circle is if I give you back this symbol. So here's my less than symbol. Say I have it's less than or equal to. Since it has its equal to bar, this is how I remember that it's a closed circle. If I move this bar and I put it right here, it closes this to make a triangle, which means it's a solid figure. So if it has that equal to sign, I can just make sure that it moves up and it closes it, which means it's a closed circle. That's one way that helps me remember. So if I'm looking at this problem, y is greater than or equal to 3, is that going to be an open or closed circle on the 3? It's a closed circle, because again it has that equal to bar. And now how do I show that you must have at least 3 years of experience? Years of experience has to be greater than or equal to 3. How would I show all the possible answers for this inequality? Well, could I have 4 years of experience and apply? Yes. Could I have 5 years of experience and apply? Yes. So, to show all the possible answers, I'm going to shade the right side of that equal to sign because everything's shaded. It could be 3 because it's filled in, or anything to the right of that. So, once I pick my open or closed circle, okay, then that last thing I'm going to do is I'm going to shade the area of what the variable, or in this case x, could be. And I'm going to put a big highlighter box around this because this is your key to graphing any type of inequality. Let's try another one. Let's try this. let's say every Mavs player scores 8 or more points in a game, which means we're going to be winning if every Mavs player scores 8 or more points. What I want you to do is go ahead and write the inequality and graph that. We'll say the variable is M is equal to Mavs player. Go ahead and write your inequality, and then I also want you to graph it. When everyone's done, then we'll push play to continue the video. Alright, since I know that the Mavs player, all the Mavs player, scores 8 or more points, so I know M and 8, now I just need to pick the inequality symbol that shows that every Mav player scores 8 or more points. So if the Mav player has to score more than 8 points, I know each Mav player has to be greater than 8, or this should be Mav player points probably. Okay, so the points need to be greater than 8. Can they be equal to 8? It says 8 or more, which means yes, every player scored 8, or it could have been 10 or 12 or whatever. So that's also going to include the equal to sign. So now I'm graphing it. So I'm going to put 8 in the middle. Now usually in basketball, baskets are 2 points depending on what kind of shot you're taking. So we're going to go up by 2s. Again, it doesn't matter. It's up to you. It's just showing the possible solutions here. So if I'm looking at every Mavs player points are greater than or equal to 8, is this going to be an open or closed circle on the 8? Again, it has that equal to bar, so it's included. So this is a closed circle. And if everyone scores more than 8, which direction am I going to shade, the right or the left? Well, 10 points is more than 8, so is 12. So I'm going to go ahead and shade everything to the right. So it should look like that. My inequality is M is greater than or equal to 8, and that is how I should graph it. Now that's from a verbal expression to actually writing it numerically. We're going to actually be solving inequalities now. So I'm going to double star this one. All you have to remember when we're solving inequalities, it's the same exact thing as solving equations, except one little thing, and we're going to get to that in a second. So solving inequalities is the same exact thing as solving equations, and we spent a lot of time the last couple weeks of solving equations, so you guys should be definitely well prepared for this. It's just really almost a review. It's just instead of an equal to sign, we're going to have an inequality symbol. So we'll start off pretty easy. One step inequalities. Let's do x plus 9 is less than 15. X plus 9 is 15. Now, again, it's an inequality because it's not an equal to sign, but we solve it the same exact way. So if I want to get x by itself or isolated, what I want to do is to get rid of that positive 9. So I'm going to subtract 9. And I'm going to subtract 9 on both sides. So I'm going to go ahead and draw my line down the middle. And I have x left over. This is a less than sign. That's where we make mistakes, is we end up changing it to equal to. But again, this is an inequality, so that doesn't change. So x is less than 15 minus 9 is 6. Now, I'm done. I simplified that. So to make this statement true, x plus 9 has to be less than 15. I can put x has to be less than 6, so it could be 5, it could be 4, it could be 3, it could be 2, it could be negative numbers, and it would still make that statement true. So x has to be less than 6. If I was to graph this, okay, I'm going to put 6 in the middle, just a couple on each side. And I want you to graph this. So if x is less than 6, open or closed circle. This would be an open circle, because 6 is not included. And if x is less than 6, that means I'm shading everything to the left. It could be 5, it could be 4, it could be 3, it could be 2, and all the negative numbers. Okay, let's try this one. Another one step. Let's do negative 12 is less than or equal to x minus 12. Go ahead and take a second to solve that and graph it as well. Okay, so again, I want to get x by itself, so instead of subtracting 12, I'm going to add 12 to cancel it out to a 0 pair. Add 12 over here. Negative 12 plus 12 is 0, is less than or equal to x. However, there's an issue here because, again, my variable's on the wrong side, so I'm going to rewrite it. Now, again, this symbol's opening up towards the x. So if I rewrite it, it has to make sure I'm opening up towards the x. So in this case, my answer is x is greater than or equal to 0. When you rewrite it, you have to flip. When I graph this, 0's in the middle, couple on the left, couple on the right. Is this an open or closed circle? Okay, this is a closed circle because our symbol is greater than or equal to. And if x is greater than or equal to 0, I'm going to go ahead and shade to the right. 1 is greater than 0. 2 is greater than 0. All these numbers, again, continuously going on and on and on, are greater than 0. So again, solving inequalities is the same as solving equations, except one little thing. I'm going to go to a new page just because I need more room. You might have lots more room to add. Okay, this is the only trick, and you will hear me say this over and over and over again. Okay, the only difference with solving equations versus solving inequalities, make sure you write this down, is if you multiply or divide by a negative number when solving inequalities, you must flip the sign. Go ahead and highlight that. That's very important. This is the only thing that's different, is if you multiply or divide by a negative number, you must flip the sign. And I also want you to put a box around by, because we're going to look at some examples where you might be questioning if you flip it or not. So we'll start off again with one-step equations. So let's do negative 8x is less than 24. One step, I want to get x by itself or isolate x. So right now it's multiplied, negative x times 8, so the opposite is dividing by negative 8, so I divide by negative 8. Now again, if you divide by a negative number, in this case I divided by negative 8, I have to flip the sign. So I'm left over with x. It was less than, now it's greater than, and 24 divided by negative 8 is negative 3. That's my answer. Now if you didn't flip it, that would not be correct. Because if I go back, if I plug in negative 8 and negative 3 goes in there, that would be a positive 24. Is positive 24 less than 24? No, that's not true. Okay, so we have to make sure that we flip it to make every single statement true. Let's try another one. Just one step, 5x is greater than negative 24. So again, I solve it like it's an equation. I divide by 5. I divide by 5, which x is, do I keep this sign or do I flip it here? Okay, this is what you have to be careful about. the number that I divided by was a positive 5. Okay, so when I divided by a positive 5, although my answer is going to be negative because the top number is negative, I do not flip the sign. So it ends up staying greater than, and when I plug this into my calculator, I have negative 24 divided by 5 to give me negative 4.8. Okay, so just because this word by makes a big difference, since I'm dividing by a positive number, it's going to stay the same. So what I want you to do is put another star and put caution. Do not change the symbol if you see a negative number. So just because I saw this negative 24 here doesn't mean I just flip the sign. It's only if you divide or multiply by that number. So if the coefficient is a negative number, that's when I flip it. I'm going to go ahead and highlight the caution as well. So as long as you remember that thing, you're going to do awesome. So let's get into like maybe some two-step equations now. A little bit more challenging. We'll just do 2. Let's do negative 3x plus 6 is greater than or equal to 18. Take a second to work on that one by yourself, and then when everyone's ready, you can check with your neighbor before we push play again. Since this is a multi-step equation, or two-step equation, I want to get x by itself. So I'm going to get rid of the number not attached to the variable, which means I'm going to subtract 6 on both sides. So I have negative 3x is greater than or equal to 18 minus 6 is 12. I'm going to get x by itself, so right now it's being multiplied, so I'm going to divide by a negative 3. On the left, divide by a negative 3. I have to remember this trick. If I divide by a negative number, I need to flip the sign. So since I divided by negative 3, I'm going to flip it to, it was greater than or equal to, now it should be less than or equal to. And 12 divided by negative 3 is negative 4. So your answer should have been x is less than or equal to negative 4. Okay, let's try last one. Let's do x divided by negative 3 plus 2 is greater than or equal to 14. Take a second to yourself to solve that, and when everyone's close to being finished, then we'll push play to go over the answer. Okay, again, I want to get x by itself, so on this left side I want to get rid of this positive 2, so I'm going to subtract 2 on both sides, which leaves me with x divided by negative 3 is greater than or equal to 12. Now this is x divided by negative 3. I want to do the inverse operation, which means since I'm dividing by negative 3, I'm going to multiply by negative 3 on both sides. So again, I'm looking for my trick. If I multiplied by negative 3, if you multiply by a negative number, you have to flip the sign. So since I did that, I'm going to flip the sign. And my answer should be x is less than or equal to negative 36. Okay, is that an open or closed circle when I graph it? Closed circle. Very good. Okay, so this is just the beginning of inequalities, just to refresh your memory from last year with the open and closed circle, and again, just solving equations. So what you're going to do is keep your notes out on your desk with your calculator. What you're going to be given is just an exit ticket with 6 questions on it. It's going to look like this. You're doing this independently, it's by yourself. You can give it as a mini quiz using your notes. Okay, you're going to solve the inequality and then graph it. So I noticed that there's work. This is where you show your work. So I would rewrite the problem right here. Okay, show me your steps. and then you are going to graph it on this number line that's already given for you. You just have to do open or close circle and which way to shade. Okay, so Miss Osborne will hand this out to you. Again, this is sort of like a mini quiz. It's due at the end of class because it's an exit ticket. So turn it in the tray before you leave. And then when you're done, you can just look over your notes, make sure that you're understanding everything we've covered. Okay, so I will see you later. Have a good day.